contestant in the final is Jamie Gallagher.
Hello, yes, I'm Jamie, and I'm a chemical physicist. And today I'd love to talk to you about sex. I've got your attention. Sadly, I'm a chemical physicist and know next to nothing about sex. So I am going to talk about something even better, and that's semiconductor physics. Because that would only help you out. Because I'm not going to talk about any semiconductor physics. I'm going to talk about thermoelectric phenomena in semiconductor physics. So what is it I hear you crying? I'm sure you're thinking it, at least. Well, it explains exactly what it is in this title. Thermoelectric phenomena. Thermal, it's about heat, and in particular, it's about temperature differences, hot sides and cold sides. Electric, electronics, and in this case, about making electricity. So far what we've got is a temperature difference, makes electricity, phenomenon, because it's amazing. So how does it work? Well, I've got one here. This is a thermoelectric generator. If I apply a temperature difference, one side hot, one side cold, this will make electricity. Inside it, there are 120 little cubes. They look just like metal, a couple of millimeters each, and they're all in pairs. One is an N-type semiconductor, and the other is a P-type. An N-type, we can think of that as a material with too many electrons, and a P-type, the opposite, missing electrons. In fact, it has positive holes. Now, if I have my pairing of the semiconductors, and I heat them up from underneath, what happens is the electrons in the semiconductor diffuse away. They move away from the hot side, just like a gas expanding. And on the P-type side, the positive holes move away. So what we have is an electrical current moving this way, and in this side, we've got a positive current moving this way, which is the same as an electrical one going that way. So I pair them up. Electricity goes up here, connect them, and back down here. I connect 120 of these along, and as long as I keep one side hot and one side cold, electricity will continue to flow. So I'm going to show you. Now, there's no denying that I'm hot. The atmosphere is quite cool. Cooler still is ice. So I'm going to make the temperature difference. I've got one of my thermoelectric generators. I'm going to use myself as the hot material and ice as the cold material. So I apply the temperature difference, and the motor spins. That's amazing. That's phenomenal, in fact. Think of anywhere there's a temperature difference. Cars are useless. They waste 70% of their energy as heat. Stick these underneath. Generate electricity from the waste heat. Solve global warming. Make me a few billion.